Hello and welcome once again to today's webinar titled What's New in Docker Desktop Enterprise 3.0. In this webinar, consultant and instructor Ken Archer will address the significance of Docker's newest features and what these enhancements mean for developers working in enterprise environments. During the webinar, everyone's phones will be muted, so if you have any questions, please enter them in the chat window or the Q&A box at the bottom of your screen. If you enjoy the presentation today and are interested in learning more about training anywhere with our interactive virtual platform called IMVP, please visit our website or contact us. Today's webinar is being recorded and we're going to send the copy to you by the end of the week. All right, now without further ado, let's get started. Ken, you can take it from here.
Good morning, everybody. We're going to get into what's new in Docker Enterprise 3.0. And welcome all. I'm happy that you all joined me today. We're going to try to cover some of the new features. I don't know, not being able to talk to everybody, I don't know who's where in their Docker journey, so I'm going to try to cover it from several angles. People that are brand new, people that have been using Docker 2.0, need to upgrade, things like that. So I'm going to try to cover several different scenarios here for everybody. So we got a lot of new features in Docker 3.0. We have updated container platform features that Docker's come out with. We have the new Docker Enterprise Desktop. Docker Enterprise Desktop is enabling developers to engage with their Docker clusters remotely in an enterprise type environment. And we're going to look more at what is entailed in the Docker Enterprise Desktop and the features that it has. Docker is also more tightly integrated Kubernetes into Docker. When you start up Docker UCP now, when you start up Docker Enterprise, Docker Kubernetes Service fires up right alongside the Docker Swarm features and provides you with two possible orchestrators and gives us a much easier way to utilize Kubernetes than just utilizing Kubernetes from scratch by yourself. I also teach Kubernetes, and I don't know how many people out there are familiar with it, how many people use Kubernetes. It's becoming more common across developer and cloud clusters, and more companies are using it and going to it. But Kubernetes by itself can be very complicated to set up, can be very complicated to run clusters, especially when you get into high availability. And that's why more and more of the large cloud providers are going to manage services, because Kubernetes is so difficult for on-prem services to utilize themselves. Groups like Google, Compute, AWS, Azure, these guys are all offering services for Kubernetes. Now Docker, with the integration of Docker into the Docker Enterprise, brings that capability much easier and simplified into the environments if you're running on-prem or even in the cloud. Docker app is a new experimental feature from Docker that they are bringing online in a few more releases. I'm not sure how long. They're not sure how long, I don't think at this point, how long it's going to take Docker app to go from experimental to stable, but it gives us the ability to merge a multi-service application into a single Docker configuration setup and be able to run a complete app with single commands. It also brings us a number of lifecycle automation tools that we can use to upgrade and backup and reset our services from a disaster standpoint. And we're going to look at those as well, along with a whole new set of security features that Docker has in Docker 3.0 that makes Docker unique in the container platform world. Right now, Docker is one of the few true enterprise-grade platforms available out there anywhere. So why do we want to use Docker Enterprise 3.0? Modern distributed architecture applications require that we rethink the way we've done things in the past. We have used legacy monolithic applications, and bringing those into a cloud environment is very challenging, if not impossible in a lot of cases. So with Docker, we can integrate with existing legacy applications, start splitting off pieces of those applications, lift and shift portions of our infrastructure into a virtualized server environment on-prem or in the cloud. This is going to, by utilizing microservice type applications, then we can start taking advantage of the benefits that we get from cloud and virtualized environments by being able to scale individual portions of our applications without having to scale the entire monolithic type of structure. We may not need everything that's involved in the monolith to be scaled across half a dozen nodes or 20 nodes or 100 nodes. We may only need one part of it to be running on one node, or we may need one part of it to be running on every node as a daemon service or something like this. And Docker is going to give us the capabilities to utilize this. We can also write apps in almost all popular languages and frameworks. I don't know of any languages right now that Docker doesn't support for utilizing to build containers and images with. We can manage brownfield and greenfield applications on the same platform. We can take existing brownfield applications, lift and shift those into a virtualized environment. We can simplify and coordinate the DevOps experience utilizing Docker Enterprise. Docker can have a separate section for the developers that they have their own sandboxed environment to run their applications, build their applications, test those applications, and then operations has their own separate production environment to keep everything safe, keep anything from blowing up from dev and blowing up in production and shutting down our business. We also have a bunch of new built-in default security features, and we're going to go into those. Now we are FIPS 140 compliant with Docker, the new Docker 3.0 engine. It is the only FIPS 140 compliant engine out there that I'm aware of. And we have SAML 2.0 capabilities and compatibility with Docker. We can now do single sign-on and two-factor authentication with Docker. So the first thing we have in Docker, we have the Docker Enterprise Container Platform. We can build with Docker Desktop. We can build with Docker App. We can build with Docker Compose. We can share across a number of different ways. We can share with Docker Hub. If you guys are familiar with Docker Hub gives us a place that we can upload our images and then share those out. Anybody that has access to our Hub accounts can download those images back, use those where they need to. We can also utilize Docker Trusted Registry, which is a registry that Docker brings to the table as part of the Enterprise Edition. And we have our own either on-prem or cloud-based registry that we can keep, control, secure, and manage all of the images that we need to run our organizational applications. When it comes to runtime, we have our container runtime, we have container management services, we have our Docker Kubernetes services, and we have our universal control plane. And we're going to get more into each of those as we go farther into the webinar here. Altogether, this Docker Enterprise Container Platform will constitute the backbone of a container development CI/CD pipeline. We can use this to secure and regulate and maintain our entire application CI/CD framework from dev through QA or CI and into production. We can streamline our workflows for faster production delivery. We can seamlessly integrate DevOps now in ways that weren't possible 5 years ago. So when it comes to the enterprise container platform, Containerd, which is our container runtime, Containerd implements, controls, and runs the containers we build. Even if we're running in Kubernetes, it implements the Kubernetes Container Runtime Interface, the CRI, and we can really radically simplify Kubernetes deployments utilizing them in Docker with the Docker UCP functions. We now have certified plugins for networks, volumes, and monitoring. Docker, working together with third-party providers, has built certified plugins that we can bring in Calico, Flannel, Weave, other types of networking into Docker. If that's something we're already using on-prem, we don't have to utilize what Docker has implemented by default. We can go ahead and utilize other things as well. For volumes, we can utilize SSH volumes, we can utilize cloud volumes, we can utilize other types of volumes for storage, and we have a lot of monitoring plugins, a lot of logging plugins with Splunk and various other types of plugins. We can monitor and see everything that's going on with all of the applications, all of the nodes that we're running out here in our clusters. We also have the ability to enforce signed images on each of our Docker engines. That way we know that the provenance of an image and its construction from the point where the developers build it, push it through whatever build server they're using, push it into the registries that you're using. We can make sure that there's signed, machine-readable metadata on each of these images that is going to give us a peace of mind when we need to pull those images into production. We can guarantee that we know where those images came from. There's no man-in-the-middle attacks. Nobody can implement some kind of malicious code into our production environment if we guarantee that those images are signed. We can force our Docker engines to only utilize signed images, so there's no way to run a non-compliant image out in our production environment. Another thing that Docker Container Platform brings us is build kit. When we do an image build, if this is a large image containing a lot of structure, it can take a long time to do a build. So build kit is an open source tool that Docker uses to speed up the Docker file build process. We can use build kit to build multi-sectional composed files in parallel, and we can speed up our build times between 2 and 9 times depending on the size of the build and the amount of work that's involved in building that. And then we have the Docker CLI. Makes interfacing with containers easy to learn and understand. The Docker CLI is an extremely easy to use platform, and based on Linux or in Windows. I use both on my computer. I can utilize through PuTTY, I can utilize Linux and go to my Linux environment, and here on my Windows machine with the Docker desktop, I can fire up in PowerShell and run all my Docker file commands right from there, my CLI commands right from there. So I want to take us a quick look here. I'm going to move over to my Docker Enterprise. I don't know how many of you guys are familiar with the Docker UCP. When you fire up Docker UCP and you fire up your swarm, you're going to be able to have a graphical user interface that is accessible from the browser. I'm using Chrome here, also accessible from Edge, and we're going to look at that in a little bit. It's also accessible from Firefox and most other popular browsers out here. We have a complete rundown of everything that's going on in our cluster right from the UCP dashboard. We can look at the number of managers nodes we have, any errors, warnings. We can look at the number of worker nodes we have. We can look at monitor the CPU, memory usage, and disk space usage of our nodes out here. And on each node, we can then go to look at the nodes in our node section. We can click on a node, and we can look under the metrics of the node, and we can see all of the pods, and in this case, containers, Docker containers that we're running out here. I'm running the DTR on my node 0, and so I'm running a number of DTR containers out here that are running my DTR. We have a number of things here in the Docker, on the Docker UCP. We have Kubernetes API docs and a live API that gives us the ability to test and check API calls to the Docker engine and see what's going to come back before we actually implement those out in our cluster. Docker Trusted Registry is the other part of the Docker Enterprise platform, and it is going to give us the ability to manage all of our resources. We don't actually store our images here in the Docker Trusted Registry. It just manages those, and we can set up storage in a number of different ways with our Docker DTR. We can set up for NFS file system, bind mounts, volumes, or we can go and set up to cloud. Right now, we have capability of setting up with Amazon, Microsoft Azure, OpenStack, and Google Cloud Storage. We set those up, set in your regions, set in all of your settings, depending on which one you're going to use, and DTR will manage all of the images that you're running out here. And I'm going to go back to the slides. So on top of that, we also have the Docker Desktop Enterprise. And it's going to bring a bunch of new features. I don't know how many people out here have been using the current Docker Desktop, which I'm using currently, but Docker Desktop Enterprise brings some new features to the table that the standard desktop doesn't. We have new MSI and package formats, be able to install the Docker Desktop Enterprise on a developer's desktop or on their laptop or wherever else the sysadmins need to implement this. We have a separate license for the Docker Desktop Enterprise other than the Enterprise, regular standard Enterprise Edition. So your administrators are able to separately license the installations of the Docker Desktop Enterprise separate from the standard Enterprise licensing that you currently use for your clusters. Another great thing for sysadmins, central configuration settings allow standard configurations to be managed and locked down. The administrator can centrally manage those configurations for all of the Docker Desktop applications that are running out here, set those up, set up pre-configured infrastructure, and implement those, then lock it down so nobody can change those from their own desktop. Swarm and Kubernetes is built into the Docker Desktop Enterprise, so you can utilize both. Utilizes the same enterprise Docker engines and CLIs that are used by your organizational Docker production clusters. So the same things that you use now are going to be compatible on your Docker Desktop Enterprise. They also have now what they call new version packs. The great thing about this is you have the version packs hooked right into your Docker Desktop Enterprise. This allows you to switch. If you're using some parts of your cluster may be older, maybe running on Docker EE 2.0, and you can switch over to Docker EE 2.0. So you can do development on your desktop environment and then do that development in the type of Docker environment that you're going to be moving that to when you run it. So all the configuration, all of the files, all the environmental variables, everything you need to use will be built in, and then you can just move it over. And you can switch with just a click of a button between the various version packs while you're working. Two new advanced features that Docker Desktop Enterprise brings us that's not on the standard desktop is application templates and application designer. With application templates, we have the ability to have Docker files. We can set up custom base images in there, set up our compose YAML files, parameter files are built in, code binaries, editor configuration files, all are composed in one application template. We can do an application template that comprises a number of different services all working together for a distributed application. So many common templates are built in, and we can add custom design templates, and we're going to take a look at those real quick. We have a number of different templates out here. This is the screen that you'll see when you bring up the templates in your Docker Desktop Enterprise. We have a Spring React MySQL template here, a Flask Nginx MySQL, a Go Nginx MySQL, Go Nginx Postgres. We have a lot of different templates that are already pre-built out here. When you're using these, you can select them and start to run them. You can run and set up and have Docker Compose working in the background, building everything while you are working in your desktop environment. And you can go ahead and start making changes in your code as everything's building. And as you make those changes, those will be put right back in to the application as you're building it. So you can build it and it goes in, and you don't have to start things, stop things. Everything is an edit and continue type of process here. So the other thing we have that builds on top of that is the application designer. We can take the multi-service pre-built application templates and bring them over into the application designer. We don't have to design and build Docker files from scratch and build our entire setup. We can take things that have already been built and customize them and use them in the ways that we need them done. So this kind of works like a graphical user interface on top of the templates that allows us to customize the settings, configurations while Docker Compose runs in the background. And the apps run in a container while we work on the source files. So you can work them, like I said, in an edit and continue type of environment. As we do this application designer, it builds now what we call a Docker app. Docker app is still in experimental stages, and we're going to get into that in a little bit. We can push applications to the Docker Hub or Docker registries, just like we've pushed our images in the past for our containerized applications. So one thing I want to get to before we get into the Docker Kubernetes service is what the Docker desktop looks like when you're running it. I'm going to get rid of that. So there's a number of features in Docker Desktop for you guys that haven't been familiar with this before. You can set your settings and set general settings, shared drive, advanced settings, network, run the daemon. I want to run this experimental, and that's going to give you some capabilities to run this in ways that you can't do with the stable version. And while that's running up, we'll go back to the slides. And we'll come back to Docker Desktop once I get that running in experimental. So another thing that we bring to the table with Docker is Docker Kubernetes Service. It's an integrated and certified Kubernetes 1.14 version currently. I know Docker or Kubernetes is currently up to 1.18, which is the edge version of Kubernetes at the moment, not entirely stable. And we bring that up. We bring up a stable version of Kubernetes, and this will, as Docker upgrades, the Kubernetes version is going to be upgrading with it. And it brings it up with the Calico CNI for our networking purposes for Kubernetes. Gives us advanced access control built in with Kubernetes, along with LDAP AD configurations, SAML 2.0 capabilities, and gives us a streamlined RBAC for the entire organization that's not easily built up with Kubernetes without a lot of manual work to do it. Docker is going to bring that to the table for us. Mutual secure TLS encryption built in, just like with the Docker container platform, the Docker Swarm platform, we're going to extend that secure TLS encryption over to Kubernetes as well. Provides Kubernetes high availability out of the box. For anybody that's ever designed a Kubernetes highly available cluster, it can be really challenging to keep this thing up and running, not have problems, do updates, and make sure that when things go down, we have more managers to keep everything else running. Docker, through the Kubernetes and the UCP service, are going to make sure that happens for us. This can be run side by side with Docker Swarm on the same cluster. We don't have to worry about just running Kubernetes in a cluster or just running Swarm in a cluster. With the UCP and the Docker Enterprise Service, we can run both of those together. We can then deploy Kubernetes applications a lot faster and more efficiently. If we go back over here to our Docker Enterprise Edition, we can get into our Kubernetes resources. We have a number of different Kubernetes namespaces, service accounts, controllers, any services running. Right now we have our cluster IP service running for our incoming cluster information or our cluster communications. We can look at any ingress controllers. Right now we don't have ingress controllers, but with Kubernetes, we have some really easy ways now to add in an ingress controller and an ingress proxy to be able to use sticky sessions, to be able to maintain connections to our containers if we need to maintain stateful connections. Also provides us with layer 7 communications capabilities that we don't necessarily have built into Kubernetes. We can look at our pods, configurations. The nice thing about Kubernetes with the Docker UCP is we can go right to creating a Kubernetes object. We can select what namespace we want to have it in. With your RBAC controls, and we're going to look at RBAC in a little bit, we're able to determine which users have access to what namespaces in Kubernetes. And so they're only going to be able to utilize things in those namespaces that they have access to. We can set up Kubernetes here. We can paste in the YAML file here, and then we're going to create a Kubernetes image out in our cluster. And Docker is going to run that, manage it, and maintain it right here from the UCP for us. And lastly, here, not lastly, but next we're going to get into Docker App. Docker App is, like I said, a new experimental component for Docker. It's just come out in Docker 3.0. It's not fully operational and stable yet, but there's still a lot of powerful tools that we can utilize with it. Basically, it's a package distributed architecture. We can package distributed architecture applications into one single file. We don't have to build a separate Docker file for everything. We can build everything as one compose file and build that out into an application that runs on our cluster. It's based on the Cloud Native Application Bundle, and this is run by the Linux Foundation, designed by the Linux Foundation, and going to provide more open source capabilities for us. We can improve collaboration by sharing the entire package on Docker Hub or DTR or whatever repository that you might be using. Improve version control, simplify build management. By doing this is one thing, we can maintain control from the development environment through the build server into our DTR and maintain good version control and simplify that for our control managers. We can also deploy multi-service applications to almost any infrastructure. We're able to build this now in multiple architectures. We can build it in AMD, we can build in AMD 64, we can build it in ARM, and we can build it in ARM 64. The great thing about this as well is we can build all these at the same time. We can build it in all 4 architectures together. So it provides us with really powerful tools and really simplified operations that we haven't had in the past. Like Docker images, Docker apps are immutable. If anybody's familiar with Docker images so far, that once you build a Docker image, that image is immutable. Changes are made into the read-write layer in the top of the container, but none of those changes actually affect the original image. We would have to go, if we wanted those changes to be permanent, we would need to commit or build the new changes into the Docker file and then update our image. Docker apps is going to act the same way. Once we build the application, it's immutable. Then if we need changes, we build those changes, set our version control, and update or upgrade our applications as necessary. It's built on the Open Container Initiative. It's OCI compliant, and it's part, like I said, CNAB is part of the Linux Foundation. Still experimental. It requires Docker 1903 or higher. It's not available if you're running an older version of Docker Engine at this point. Installed as a CLI plugin. We're going to run Docker app commands, just like we run Docker image commands, container commands, network volume, what have you. We're also going to run Docker app commands. It's installed as a CLI, and then we can build, validate, and deploy applications with the Docker app command. So we're going to go back here. I'm going to do a quick demo with I'm going to need to pull Putty back up. And sorry about that, guys. My Putty session shut down on me, but we'll have it back up and running in just a second. Okay, so we can run Docker, like I said, Docker app, just like we run Docker, the other commands inside of Docker. If I do a Docker app -- help, it'll give me a complete list of all of our Docker commands. Docker app bundle, create a CNAB invocation image and bundle for the applications. Docker app completion, init, inspect, install, list, merge, pull, push, render, split, status, uninstall, upgrade, validate, version. So we have a complete list of Docker commands that we can use. I need to set that a little smaller. And I have some Docker, a Docker file already run that I can use a Docker command to manage. I can validate a Docker application that I have running out here. I validated a hello world. Now I have a complete application package. If I do it, let me clear my screen here. And if I do a Docker, if I do an ls here, I've got several YAML files here. If I look at the Docker compose YAML, it shows that I've got a number of, I've set up a service running a HashiCorp HTTP echo image, and I can look at this application. I can look at the Docker app. Oh, that's a directory. Sorry about that. Oh. There we go. And we're building the application. And if you set this up and you run a Docker application init, it's going to set up compose files for you. You can set this up individually for each compose file, or you can set that up like I have here as one compose file with different sections. This section, we have the name of the application, description of the application, and the maintainers for our application. We also have our compose file, tells where we get our information from for running our actual application. And we set up a section with the default values for the application parameters. Like I said, we can run this as a single file or as a multiple file. So we're going to set up an application here. And this is extremely easy. We run a single application command, docker app install, hello world docker app, and the name of it. It's up and running. And I can look at my Docker applications. Here I have my app hello world installed, success, 7 seconds. And it's that easy to set up and run a application in the Docker app. We can also shut these down. We can run it as a stack. We can run it as a compose file. There's a number of ways that we can run this that give us capabilities and tools that we haven't previously had in Docker. Find my slideshow again. So we also have lifecycle automation tools. Centralized cluster management with our Docker UCP brings us the availability to run and monitor everything from one location. We can integrate with your favorite monitoring tools. If you use Datadog, or if you use Splunk, or if you use Rancher, or any of the other monitoring tools out here, you can integrate those with Docker. Odds are they have a plugin, or they already have pre-built Docker certified images to be able to run those. We can secure our access with the existing LDAP or AD infrastructure, and we're going to look at that here in just a second, how we quickly and easily bring in LDAP into our Docker UCP. Docker cluster CLI tools work with AWS, Azure, vSphere, and we're going to get into that when we look at Docker cluster. We can run Swarm and Kubernetes in the same cluster. Typically, we're not going to run them on the same node because Swarm and Kubernetes have no idea what each other are doing, but we can have 10 nodes out here running Kubernetes, 5 nodes out here running Docker Swarm, and Docker UCP is going to be able to manage all of that for us. Simplify with automated tools for upgrades, backup, disaster recovery, scaling. We can easily set up all kinds of standard upgrade procedures. You can use canary upgrades, blue-green upgrades, parallelized upgrades, and updates into your production environment, just like you've been using in the past. So I want to get into a quick demo of Docker's capabilities with LDAP. I have a LDAP running over here, and I have my Docker UCP. And I can set this up in my operations in admin settings under authentication and authorization. I can set that up to run LDAP. And then I can set up my LDAP server. Let me grab the command I need. here. So I'm going to add in my search settings, reader password, and set up my search configuration. Search subtree instead of just one level, and confirm. And confirm that we are set up. I'm set up with my LDAP. Now you can set this up a couple ways. You can set up just-in-time user provisioning, or you can set up so that it configures automatically with everybody. Typically in an organization, you're going to use just-in-time user provisioning, so there's no assets that are attributable prior to a user logging in for the first time. But for my operations, I went ahead and set up everybody from the get-go. And I gotta go back and enable that. And I forgot to save it. Save it already. Okay, now I go back and should integrate my users and teams into my organization. It may take a minute to get that set up, depending on difference where my LDAP is set up to where my organizational setup is. So that brings us into Docker Cluster. Docker Cluster is also a fairly new tool for Docker. It is a CLI tool for managing Docker cluster lifecycle, a three-step process that we use for Docker Cluster, that we're going to build it, validate it, and deploy it. We can easily create or destroy new clusters, scale clusters up or down as necessary. If we need to add new workers, the Docker cluster command provides us with an easy way to do that. Upgrade clusters to new Docker engines. We can inspect cluster metadata, look at what information is out there about our clusters, and we can easily back up and restore clusters with the Docker cluster command. And we're going to move to the CLI command, and Docker cluster commands work just like all other Docker commands. You have the -- help file, just like all other commands. We can back up, create a new Docker cluster, inspect, get detailed information about the cluster, list all available clusters, restore cluster from a backup, remove clusters, update running cluster's desired state, version, print the version, commit, build type of the cluster. Right now, Docker cluster is available in Microsoft Azure, AWS, and it's coming in vSphere. I'm not sure if it's totally up and running and capable in vSphere yet, but they are working on that. You have to have the available credentials to be able to use Docker cluster in the environment you're going to run. You set up your variables, or you set up your credentials, and then you run your cluster command and can set up a new cluster. And this is what the cluster YAML will look like. You set up a YAML file, and it's going to set up all of the information you need. Set up your region, set up your password, set up your provider, the engines that you're going to be running, the version you're going to be running in UCP, and how many instances, managers, workers that you want in your cluster. And then you do a Docker cluster create, and you fire up a new cluster in your AWS or your Azure or your vSphere environment. It also brings us to enhanced security features. Now with Docker, we have the capability of SAML 2.0 compatibility. Gives us the capabilities of utilizing two-factor authentication and single sign-on with UCP, where once we're signed on with the organization, we can already be signed on with the UCP. We can already be signed on with our DTR. Currently supports Okta and ADFS, but Docker is working on bringing this to the table with more providers in the future. We also are the only validated, NIST validated FIPS 140-2 compliant Docker engine. This has to be set up and enabled on the Docker engine itself, but then provides the extra security capabilities of the compliancy. We also have Docker and Kubernetes secrets that give us the ability to manage and move secrets around our cluster environment with mutual TLS encryption when the secret is sitting at rest and when it's in transit from the Docker Swarm Manager or the Kubernetes Manager to the working pod or the container where that secret's needed. Docker Context is a new feature of Docker that enables us to partition separate users. We can set up Docker Context just like we can set up Kubernetes namespaces, and then allow certain users to have capabilities within that context and lock other users out of it. So we can have our own context for individual dev groups, and then those contexts are separated and isolated from the other users. We could have dev team red, dev team blue, and they could have their own context set, and then their areas are sandboxed from each other and provides us with layers of separation and isolation and protects our environments. We also have PKI capabilities now with Docker. Public key infrastructure, we can manage authentication without passwords. We set up the PKI, download a client bundle, add that to our local machine, and then we can set that certificate up with our browser, and our browser will run that certificate against our Docker UCP, and we can use passwordless logins into our user interfaces, either with a DTR or with the UCP. We don't have to sign out, sign in. We don't have to worry about losing passwords. We don't have to worry about accidentally getting our password out in the clear. It's going to give us the capabilities to run our applications more securely, especially if that's what we're using in our organizations. So with that, I want to find out, let me drop this out real quick. I need to pull up my participants page and the chat page. Are there any questions? Does anybody have any questions about anything we've covered so far?
Just a friendly reminder, if you do have a question, to enter it in the Q&A box or the chat window at the bottom of your screen.
And I'm going to go over pull this up here, because if I go back to the presentation, it will drop my...
There are no questions at this time.
Okay. So we have a CED accelerator that you guys are welcome to check out. Our accelerator can transform your development instance into a compliant enterprise container platform. Our engagements increase the velocity of future releases. We can implement operational security and regulatory requirements while maintaining and moving our updates into our cloud environments. We can upgrade existing Docker CE instances in place without having to change anything. And we're offering everybody who came to the webinar and everybody who registered for it a 5-day free trial of a complete 5-node Docker EE cluster. Will include 3 managers, 2 workers, and a Docker trusted registry. And you can use it and experiment with it however you want for 5 days. And you can get there from our website at, let me pull that back. And I'll type that in here in the chat. It is stonedoorgroup.com/docker-ce2ee. And if you put that in, go in, and you can get a 5-day free trial of Docker. And if you're just getting started with Docker, did you want to cover this or did you want me to?
Well, you're on a roll, Ken. I think you
Okay.
can speak on these if you like.
Sure. And so Access Certified provides a lot of different training with Docker. If you guys are just getting started with Docker or have new teams that are getting involved with Docker, then they can provide you with all kinds of training and different capabilities. They have that in their accesscertified.com/training/Docker website. We have a Docker Fundamentals and Developer Bundle. There's Docker Fundamentals by itself. There's also the new Docker Cube Intensive Training, Docker Troubleshooting, and Docker Developer and Docker Enterprise can be taken singly as well. And you have the Docker Fundamentals and Enterprise Bundle. So with that, that's all I have for the class. Is there anything else anybody would like to ask?
Thank you so much, Ken. We will leave some time to post questions in the Q&A box or the chat window. As those questions do come in, I just want to remind everyone that we recorded this session. We're going to send a copy to each of you by the end of the week. So, Ken, it looks like we do have a question from Mike in the Q&A.
Mike, Mirantis acquired Docker. When did that happen? That's the first I'd heard of it. I wasn't aware that that news broke an hour ago. Wow, that's why I didn't hear about it. No, I had not heard. I knew that the Docker was going to be probably up in the air for acquisition here shortly. The guy that took over Docker as CEO back in July, his entire resume has been taking companies and opening them up, setting them up for acquisition by other companies. So that's brand new to me, and I will be looking into it because that's going to change a lot of things out there, maybe with Docker. And hopefully it will give them the ability to make some improvements. Any other questions?
All right, thank you so much. If you have any further questions, or if you're interested about our curriculum of Docker courses at Exit Certified, you'll find the link over to our training page in the chat. If you do want your 5-day free trial, visit stonedoorgroup.com/DockerCETE. Both links are found in the chat window. We look forward to hearing from you. I hope you enjoy the rest of your day. Thanks again.
Thank you, everybody. I appreciate you guys coming out and watching, and I hope we've been able to get you some good information and interesting information about some of the new features.